The global demand for artificial intelligence is currently outstripping the available supply of engineers capable of building it. Yet thousands of recent graduates holding degrees in machine learning are struggling to secure employment. This discrepancy exists because the technology sector is undergoing a systemic macroeconomic shift, changing how capital is allocated toward production. For decades, the industry relied on linear scaling, a model where increasing production required hiring a larger pool of human labor to manually write more lines of code. This diagram illustrates the transition. Growth is moving away from labor-intensive toward compute-intensive models. The old model spent 70% on human labor. The future model shifts that investment, allocating 60% to raw compute and just 25% to the specialized experts orchestrating it. Because the majority of capital is now buying machine intelligence rather than renting human time, the model of mass software engineering hiring is replaced by what the industry calls class hiring, the recruitment of small, elite teams to manage massive compute resources. This cost structure suggests that while AI may not replace engineers broadly, it will replace those who understand theoretical concepts but cannot orchestrate this new scale of compute intelligence. This shift exposes a structural gap in how artificial intelligence is currently taught in academic settings. Academic programs often present machine learning and deep learning as isolated theoretical subjects, detached from live, integrated systems. This creates fragmented knowledge. Students spend years on unstructured tutorials, only to graduate requiring extensive training to contribute to a production-grade codebase. That theoretical focus stands in direct conflict with a job market that prioritizes full-stack execution. The hiring reality today is built on interlocking gears of execution. Top employers expect engineers to build complete products, deploy applications to the cloud, and work with live, real-world data. To bridge this gap, a student must transition from the role of a passive learner into an active systems builder. AI competency is a hierarchy of technologies where skills must compound upon one another in a specific sequence. This blueprint outlines the 6-layer architecture of a modern AI engineer. Before reaching the generative frontier, a builder must secure the 2 foundational layers, data BI and AI ML deep tech. The first month of this stack focuses exclusively on structural data processing, the prerequisite for any functional AI system. This layer requires mastering full-stack Python programming, executing web scraping, and establishing database connectivity for raw data ingestion. Month 2 progresses into data wrangling, requiring the use of pandas and NumPy to clean and structure that data for analysis. This sequence is critical because predictive models are ineffective without pristine data and a grasp of the inferential statistics used to validate their outputs. To make data legible to a business, engineers also integrate visualization tools like Tableau and Power BI, translating raw variables into clear business logic. With the data foundation in place, the stack advances into the core layer during months 3 and 4, moving from historical analysis to predictive modeling. This stage requires building and evaluating over 15 classification algorithms, including XGBoost and random forests. Optimization at this level requires the builder to execute precise hyperparameter tuning and feature engineering to maximize model performance. These models are then taken out of the development environment and deployed as interactive web applications using Gradio or Streamlit. This deployment capability allows for a transition into deep learning and computer vision, utilizing CNNs and neural networks for object detection and image analysis. Mastering this predictive core is the technical threshold that separates a basic data analyst from a machine learning infrastructure builder. Once the predictive core is established, the engineer can move to the generative frontier, occurring in month 5 of the curriculum. The technical baseline for this frontier is the transformer architecture. Its attention heads and data routing drive every modern language model. The execution requirements involve building retrieval-augmented generation pipelines to ground model responses in external data. Engineers also fine-tune models like Llama or Falcon for specialized, domain-specific tasks. This goes beyond basic prompting. It requires an understanding of semantic similarity and how data is mapped in high-dimensional space. Builders use embedding frameworks like Word2Vec and BERT to transform human language into the vectors the machine can process. This culminates in the apex layer of the stack, agentic AI, executed in month 6. Agentic AI represents a move away from passive language models. An AI agent is built with perception, memory, and the autonomy to take action within a software environment. Building these systems requires mastery of orchestration frameworks like LangChain, Llama Indexed, Crew AI, and AutoGen. This enables a shift toward multi-agent workflows, where the goal is no longer a single chat response, but a completed business process. In these workflows, specialized agents cooperate and negotiate, calling APIs and browsing the web autonomously to solve multi-step problems without human intervention. Industry value is moving away from simple model queries and toward the orchestration of these autonomous multi-agent systems. Acquiring this stack requires an environment built for high-frequency iteration and structured execution. This is the innovation flywheel, the daily operational methodology of the program. The first half is dedicated to morning concept learning, focusing on technical seminars. This is followed by afternoon coding labs, applying theory through hands-on prototyping. This daily rhythm creates a compounding effect over 1,200 hours of training. By the end of 6 months, this cycle produces a tangible repository of over 100 portfolio-ready projects. This volume of work provides the concrete evidence needed to overcome the lack of experience objection. All these skills culminate in a single deployable output, the startup-ready minimum viable product, or MVP. The builder takes the raw materials from over 100 mini-projects, like AI tutors or medical imaging bots, and prepares them for integration. The MVP engineering process requires unifying these fragmented components into a cohesive, functional application. The final architecture is secured through product design, cloud deployment, and API integration, ensuring the product is ready for users. This brings the engineer's output in line with how the industry now allocates its capital. Modern tech firms allocate resources towards proof of execution, verified GitHub repositories, and live web links, moving away from a primary reliance on academic credentials. The future belongs to the builders, those who can step past theoretical concepts and physically architect this new era of compute-intensive machine intelligence.